So, how much time passed between the research paper and having the idea for like the company, as far as like just, this could be something?
That was very quick, almost immediately. That is kind of like that was the very natural next steps and kind of like scaling law. Okay, what happens, if we were to instead of doing a GPT-2 size model, what would happen if we were to do a GPT-3 sized model or GPT-4 sized model? Would we still be able to match the quality with a model that was like, let's say, 10x faster or cheaper, because those two things are basically the same. And so the question of is this possible immediately came to mind. And of course, it was, easy to understand that if that was possible, it would be extremely valuable, right? Just based on the evaluation of OpenAI and Anthropic and like market size and the growth at which, like these companies are, growing. It was pretty clear that if this was going to work, it would be huge. And so almost immediately after, I started thinking about, okay, how do we take this to the next level?
Stefano Ermon is a computer scientist, a professor at Stanford University, and founder and CEO of Inception Labs. He started with a research paper that showed a new way to build language models, then faced a very different founder challenge, convincing investors that the idea could scale from an academic breakthrough into a venture scale business. In this conversation, we talk about what he calls the 10x rule for startup differentiation, why Inception Labs built before talking to customers, what he learned going from researcher to CEO, and how he thinks about competing with companies like Google and OpenAI. I'm Walter Thompson. This is Fund, Build, Scale. Fund, Build, Scale is for anyone who's interested in learning the basic skills required to launch a startup, secure initial funding, and transform their idea into a sustainable business. Get the newsletter on Beehive or LinkedIn, and subscribe wherever you get your podcasts. And if you like what you hear, please leave a rating or review. Stefano, thanks for joining me today. I appreciate it.
Yeah, of course. Thanks for hosting me.
A lot to get into, but for listeners who aren't coming from academia, what was the problem you were actually trying to solve when you first started thinking about diffusion-based language models before you actually started the company?
Yeah, so the problem is pretty simple. Like everybody is using, LLMs. The demand for, various kinds of agents in the coding space or customer supports, various kinds of assistants is booming, and companies cannot keep up with this demand, and they need to build massive data centers to support all these new use cases of generative AI models. And the fundamental issue is that everybody is essentially building on the same kind of approach, which is something called an autoregressive model that essentially, if you've ever interacted with ChatGPT, you'll probably see that when you ask a question, it will give you an answer and it will do so one word at a time, left to right. And that's very, very slow. And there is basically this fundamental bottleneck that is built into the way Anthropic or OpenAI or Google is building LLMs, large language models, which is kind of like the core component of all generative AI solutions today. And the reason I started Inception was because we had in mind a completely different approach that is significantly more scalable, significantly more efficient, an approach called the diffusion language model, where essentially you're able to generate many words at the same time. It's a much more parallel type of approach for generating text and code. And we had this insight that if we can train models at the scale of our competitors, we would be able to match their quality while being significantly faster and much more cost effective. And so eventually it's all going to be an inference game. We need to be able to support an enormous number of new applications and use cases of LLMs. And the solution that scales better at inference time is the one that is going to win. And by breaking this sequential bottleneck of all the existing LLMs, we were going to be able to have something fundamentally better, fundamentally more scalable.
And you said in the past, this started as a paper with really strong results. It wasn't intended to be a product, or you weren't building it as a product from the start. Let's talk about that. What was missing from that paper that kind of forced you to think more like a founder than a researcher when you were thinking about bringing this to market?
Yeah, so I've always been a researcher. Like that's kind of like my DNA. I've been doing research in what's now called generative AI for like probably more than 10 years. So well before, this was cool, I was already thinking about how to build various kinds of machine learning models that can generate images, can generate video, can generate text. So I have always been interested in exploring like what's possible, what's the best way of creating these kind of models. And as a researcher, I saw that there were kind of like two main approaches for building generative AI solutions. There is the autoregressive kind of approach where you generate, let's say, text, again, left to right, one word at a time. And then there's the diffusion approach, which is currently the best approach for image generation, video generation, music generation, where instead you kind of like generate the output in a coarse to fine way through a process of gradual kind of like improvement, where you're able to modify many components of the object in parallel at the same time. And so as a researcher, I was very, very interested in understanding why is there this difference? Is it possible to take the more scalable solution that currently works best for images and video and other things and apply it to text and code generation? And so in my research group, we've been working on that approach for a long time. And eventually we had this breakthrough that you alluded to, this paper where we basically figured out how to apply this technology to text and code generation. We published a paper essentially showing that for the first time, it was possible to train a diffusion-based language model that was able to match the quality of a traditional autoregressive left to right model that everybody else was building, while being about 10x faster. But the result was only done at the scale of a GPT-2 sized model, so less than 1 billion parameters. So, that was kind of like the largest model it was possible to train, given the resources we had in the lab. So given the amount of compute that we had access to in the lab and the kind of like level of engineering support that was possible to have there. And of course, that was super promising. It was very, very exciting. And the paper won a best paper award at ICML, which is the top machine learning conference. But that's not enough because, of course, the quality of a GPT-2 size model, it's not sufficient to support any kind of like real world generative AI solution, right? You need to have larger models that have been trained on more data to be able to have the kind of quality you need for serving production traffic. Mm-hmm. And so I decided to start a company to essentially scale up and train larger models, more capable models that would support real world use cases.
So how much time passed between the research paper and having the idea for like the company as far as like this could be something?
That was very quick, almost immediately. That's kind of like that was the very natural next steps and kind of like scaling law. Okay, what happens, if we were to instead of doing a GPT-2 size model, what would happen if we were to do a GPT-3 sized model or GPT-4 sized model? Would we still be able to match the quality with a model that was like, let's say 10x faster or cheaper, because those two things are basically the same. And so, the question of is this possible immediately came to mind. And of course, it was, easy to understand that if that was possible, it would be extremely valuable, right? Just based on the valuation of OpenAI and Anthropic and kind of like market size and the growth at which, like these companies are, growing. It was pretty clear that if this was going to work, it would be huge. And so almost immediately after, I started thinking about, okay, how do we take this to the next level?
So we spoke briefly before, and you mentioned that your first big challenge was de-risking the idea for investors, not actually finding customers for it. What specifically did you need investors to believe before they were willing to fund you?
Yeah, so they needed to believe that if we were to throw essentially enough capital, enough resources in terms of like compute and data, we would be able to, increase the quality of the answers that are generated by these models and be essentially comparable to what people are able to get with the traditional approach. And so the simplest way to think about it is some kind of like scaling law, where on the x-axis you have something like money, essentially, or investment, which is a mix of, let's say, compute and data. And on the y-axis, you sort of have quality. How good is your model at the end? And so if you can kind of like provide a few data points showing that, yes, if we were to throw more resources at it, we would be able to get to, there's a credible path towards frontier level intelligence. That was the kind of thing that I thought would be very, and we agreed upon with our initial investors, that would be the proof point to kind of like go to the next level, raise more capital, and then, keep building out this technology.
You did raise pretty quickly then. So how much time passed between releasing the paper and your first meeting with an investor?
That was pretty quick. I would say a couple of months, we immediately were able to raise a pre-seed round to kind of like get things off the ground and go to the next scale. So yeah, that was quick.
AI investors, they're hungry for the opportunity, certainly, and power law investing and the rest of that. But I mean, did you need to show them what evidence were you able to show them that compensated for the fact that really this was just mostly technical risk at this point?
Yeah, the evidence was basically the paper and the credentials of the team. So that was the other thing that I could sort of like do very
Mhm.
quickly was to assemble a team of co-founders that were, you know, some of the best researchers in the space working specifically on diffusion models. Those were people that were in my network that I had known for a very long time. And so from day one, we had a really, really credible team of really strong researchers that were world experts in that particular domain. And so we kind of had the best team to explore this idea. We had some initial proof points that was possible. That was the paper. A lot of excitement from the community, like a best paper award at the top machine learning conference from tens of thousands of papers that get
Mhm.
submitted. So the ingredients were there, and of course there was a big reward at the end because if this works, it would have been really really big. And so it was actually pretty easy to convince investors that this was fundable and this was a good investment opportunity.
What were your challenges kind of taking a very technical story with a lot of technical risk and explaining it to non-technical investors who couldn't see everything you could see?
Yeah, so two things. One is one of my co-founders was actually a former entrepreneur. So he was a PhD student with me at Stanford. After graduating, he started a company, also a very technical company, where they were building machine learning models for optimizing supply chains in supermarkets. So it started from a research idea again that they had on campus, and then they turned it into a very successful company that is now, that their technology is used in a large fraction of all the US supermarkets. And so having Vladimir, this one of my this co-founder on board from day one was super helpful in terms of like, you know, de-risking the team and telling investors, look, we have people on the team who've done this before. At the same time, I mean, of course, he had a lot of experience in terms of like, how to start a company and how to be as efficient as possible with time and resources that you have at the beginning. And so a lot of the processes, a lot of the way to think about, you know, bootstrapping something from nothing, he had gone through that process, so it was extremely helpful to have him as a co-founder in those early days. That was one thing. The other thing is just to look for investors who have a technical background and understand the value of this technology. Naveen, who led our pre-seed round from Mayfield, he's also a Stanford PhD dropout who really understands the technology, and so of course, you have to find the right investor who understands and is willing to make these kind of bets.
How big is the founding team, and how did you decide how to slot individual people into individual roles? Like who's going to sell, who's going to be the CEO? How did you divide and conquer?
Yeah, so the founding team initially was just three co-founders, me, Aditya, and Volodymyr. So essentially, me and two former PhD students. Aditya and Volodymyr, they were classmates. They had worked, side by side for 5 years at Stanford. So they've known each other very well. And of course, I had worked with them also for a long time. And so we all knew each other. We knew we worked really well together, and we are very aligned in terms of like how we work, how we think about problems. And so the challenge was basically convince them to join this venture, but they they also were working in similar spaces, and so they understood that the potential was huge. Um, in terms of the roles, it was pretty natural for me to be the CEO, just like because of the kind of relationships and dynamics that we had. Me being their PhD advisor, it kind of like made sense for me to be the CEO. And then Aditya took over the CTO role, kind of like thinking about all the infrastructure and platform and getting the compute and all that side of the business. And Volodymyr is the chief scientist. And from day zero, started thinking about, okay, what does it take to de-risk the approach, and how do we think about building a science team that can help us sort of like scale the models and understand what is the best way of training a diffusion language model.
When was the seed round?
That was summer 2024.
Pre-seed.
After that, there was another larger round, summer 2025, that
And
we
how
raised.
and how big is the team now?
It's over 30 people.
I wanted to talk also about building a customer base without doing kind of a formal customer discovery process. You're pretty explicit that you started building before you had customers, which runs counter to a lot of startup advice. What made that a rational choice and not a risky one?
I think it was, rational in the sense that it was clear that there is demand for LLMs, and it was clear that sort of like if we are able to match the quality of existing models while being faster or cheaper, there would be demand for that. So just like based on conversations, based on friends and colleagues that are kind of like in industry and working every day with LLMs, like it was clear that cost and speed were, main pain points. And we could see other ventures like companies building chips, like Cerebras or Grok, that were doing really, really well, essentially trying to address exactly the same pain point, trying to make LLMs go faster and cheaper on the hardware side. So taking a different solution to the same problem. So there was enough sort of like validation that if we could succeed on a technical point of view,
Mhm.
there would be a market for something like that.
Right. Although, succeed at what almost is the question I would ask, right? Like you didn't know at that point what the model would be best at, like latency or hallucinations or coding or what. So how did you stay focused when you didn't actually know what the strengths were? Like when the strengths of the technology weren't fully revealed, how did you stay focused and on track?
Yeah, that's a great point. Initially, we weren't sure what would be the kind of like emerging capabilities of these new kinds of models, and so again, we took some bets. Initially, we focused heavily on coding as a use case. Again, as a way of
And
trying.
wait, was that like because you're looking at the TAM or just because you thought that might be a good way to go?
A combination. One was, it was clear that coding works and coding was going to be there for a long time, and it was going to be a big market. So TAM was one thing. The other one was just like, we all have PhDs in computer science, so we understand the vertical very, very well. So if I were to train a legal LLM, we would not understand, is this good enough or not? We would not understand just like just sanity checking, the quality of the models. Are they doing the right thing? Is this
Mhm.
interesting or not? Coding is very, very close to us. And so we understand if we have something good or not very, very quickly without, external feedback, external help. And there were also technical reasons for why training on code was actually uh, a good sort of like application for these kind of diffusion based models. The reason being that if you think about code, it's a little bit less left to right compared to just traditional text. Think
Mhm.
about a big code base, there's a bunch of files and they're not necessarily in any particular order. And so the idea of having a diffusion type approach which can take the whole code base and figure out how to modify it, how to change it based on what the user wants, also made sense intuitively. And so it was a combination of things that made us bet on coding as the initial use case.
And can you, looking back, was there a moment you could look at where you realized, okay, this is no longer just an impressive artifact. We actually have something customers will pay for?
Yeah, it happened pretty quickly after essentially training the initial model and kind of like figuring out how to serve it in for real and to be able to handle production traffic. So there was a lot of kind of like software engineering work in terms of like figuring out how to take this artifact and then map it down to something that can be served efficiently using GPU clusters and dealing with all the complexities of real world production traffic. Once we had that, and we had basically a working end-to-end prototype, and we were able to see, we had external companies that are essentially benchmarking LLMs, and they can tell you, okay, your LLM has this level of intelligence and has this kind of speed. After they benchmarked it, and indeed they were able to see that, it is 10x faster than anything else that exists with that level of speed. We just put it out on social media and it immediately went viral. Like we had millions of views, a lot of top researchers and industry leaders in the space started talking about it. And so it went viral immediately, and we got a lot of inbound from customers that were interested in, can we try it, can we use it? And so that's how we did it.
When you're a first-time CEO with no sales background, you stepped in without, prior sales experience. And you mentioned like the volume of rejection was kind of a surprising thing to you. Kind of the before and after. What did you initially believe about selling that turned out to be just wrong?
I thought it was mostly about the tech, that sort of like if your model is better, then that's it, and they will just buy it, and so that it's purely sort of like a technical issue. Um, and then I quickly realized that no, that there is all kinds of other constraints, and there is a lot of interpersonal dynamics, and that the whole sales process, it's very complex, and that there is other factors at play that are also really really important in getting us from okay, there is a really cool solution to a problem to actually making the sale. Yeah, there were many other factors that are also very very important.
I know you were focusing early on kind of CTOs and VPs of engineering and really technical executive decision makers, not like business straight enterprise buyers. Was that a choice you made because of your thinking about how to approach the sales? Did that approach reveal itself after trial and error?
That was pretty natural in the sense that's the kind of network that I already had, having been, in the tech industry for a long time. I already had a lot of connections to tech leaders in, companies, various verticals and at various levels. And so that was kind of like a very natural way for me to try to get feedback on is this useful for you, and of course having a prior relationship with these potential buyers is super helpful. And so that was the strategy that was most natural to us, and I think it is the right one, because of course it's a very technical kind of like solution and approach, and it requires a very technical kind of like buyer on the other side.
So, what did those early conversations teach you about how technical buyers approach and evaluate risk?
Yeah, that sort of like there is many factors. One of it is indeed sort of like, does the solution actually work? And they want to be very, very rigorous in terms of like evaluating it in different ways, offline, online, doing A/B tests. There is a pretty common sort of like pipeline of various stages at which they evaluate your solution from a technical perspective. But then there are other factors, like, they're worried about compliance. They're worrying about, okay, can we rely on a startup that might be going out of business in 6 months, right? And all these other things. that are also super important from their, of course, from their perspective that we learned were also important to kind of like communicate and be proactive about in our messaging.
And since you didn't have a lot of experience with like pricing and procurement, you kind of leaned on your investors to help you with that. How did you realize that you actually needed that help? Like, because again, I know like pricing something that's brand new, like a category creating kind of a thing, you're looking for comps. Like, what was your initial process as far as kind of trying to come up with your own pricing thing? And then how did it change, I suppose, after you brought the investors in?
Yeah, so it's a mix of course, working backwards from, how much does it cost us to serve these models, and then how much are competing models of similar quality, similar speed being priced at by competitors, and what kind of margins do we want to have, and what kind of premium can we charge, because we have such a faster and differentiated solution. And so it was a little bit of trial and error, but also, yeah, discussions with our investors that had been on the buying side, and they were helping us think it through, and you know, for example, saying things like, "Oh, you don't want to go." If you make it too cheap, even though you could make it really, really cheap, then the
Right.
perception might not be the right one. And so, uh, again, there is many factors to be considered, and we try to balance them, and come up with something that would, be well received by our customers.
I mean, looking back at your own experience, was there something you did or your team did, like one kind of early mistake that you would never make again because you just know better now?
I think we initially talked to heavily regulated industries, and I think, yeah, that was in hindsight obviously a mistake, because they're very risk averse, and eventually they'll probably get to work with us, but it's gonna take them longer to sort of like figure out and be able to take the risk to work with a small startup that might not have all the compliance check boxes yet. And so, yeah, in hindsight, we probably could have saved a bunch of time not going after clients in this very, very regulated sort of like industries.
I've talked to a lot of AI founders, and there's a lot of worry that, when one of the giants like, updates their model, it can kind of make everything you're working on just like irrelevant or, kind of eat your lunch, kind of, I guess would be the colloquial way of saying it. When you saw that Google is working on diffusion, that they had made big leaps, what was like the first thing you thought as far as concretely, what did you think was going to happen to your company?
Yeah, that's interesting. Initially, I thought, okay, this is really bad news for us. They are gonna take over, and this is terrible for Inception. Um, Quickly, I realized that it was actually good news for us. We had planned to do all of this work to, get the models in the hand of customers, and kind of like build the evidence that indeed this technology works, and that it's going to be the future of how people build LLMs and so forth. And sort of like, we had this plan of all these customer engagements and all this work we had to do to kind of like show our investors that indeed this is the future of, of LLMs. Then Google comes and says, "Oh, we're also building on this, on this technology. We're also excited about this. We also see that these models are so fast," and immediately that validated the technology and what we were doing overnight. And so immediately investors started to reach out to me asking for to talk, and so eventually them showing the world that they're also working on this, that they are also betting on diffusion LLMs, validated the approach, validated the technology, and it was actually good news for us, especially because they have not actually then released the product based on that. So
Hmm.
it was purely like a demo, something that they, it was a blog post, it was a bunch of numbers, which were actually not even better than what we had in our from our model. Sundar Pichai talking about it at their event, but eventually it did not translate into a competing product that they were going to sell to their customers. And it was purely kind of like a research demo that just validated the approach. And so eventually it was actually good news for us.
That is good news. What was the actual danger to Inception Labs in that moment? Like, was it that like they could beat you on performance, they could take your customers, or because of just like their scale, they could just make you irrelevant? What was the biggest danger, actually?
Yeah, I think I would say it's a combination of all of them. Just like, if Google decides that this is what they want to do, of course, they have more compute, they have more data, they have more people, and they can outcompete, anyone. And so if they were gonna bet big on that technology, it would have been very hard to keep up with them, right? So the whole idea here is that, we're the first movers, we have sort of like a competitive advantage. We have maybe 12 months or 24 months kind of like lead over everyone else in the field. And, if we keep running, we can keep that lead and we can always have the best diffusion language model on the market. If Google decides to invest heavily on this and they are further ahead than we thought they were, then that's a problem for us, especially, because the resources they have, the distribution that they have through
Mhm.
GCP and all of that. Um, and so that was sort of like the risk in our mind that we would be irrelevant because they are quickly going to win the race and it would be impossible with the kind of resources we have to catch up with them.
I mean, this is probably an unfair question to ask, but if Google came to you today and said, "Hey, what about, we buy Inception Labs. Are you open to that? Can we acquire you and just kind of do it together? Do you want to build this on your own, or is this something you'd be okay like partnering with a good partner that you knew could take it to the distance, basically?"
Yeah, I mean it's our intention to definitely stay independent and I don't keep building this technology. I think that it would be very hard to do it as part of a Google or one of these other large uh, tech companies, just like because there's so much you know inertia, so much red tape. It's so hard to move quickly within one of these big organizations, and so the ability, the speed that you have at a startup is just like so important to keep running, right? And we're seeing it even with OpenAI, Anthropic being able to outcompete Google right now. It's because, or some of it is because they can just move faster and it's more lightweight, and the whole company is focused on that single objective as opposed to just being a part of a much bigger sort of like organization.
Mhm.
And so there is an enormous amount of upside and we can do it independently. So it definitely makes sense to build another OpenAI or build another Anthropic. That's the kind of dream that we have, and it's very much possible to do it. So by staying independent.
I mean, did anything change materially though for you? Like like the week that Google made the announcement, did anything change the way you operated like that week or the next week? Did you move faster? Or did you shift priorities? Or is it really kind of just, hey, this is a good validation signal. Let's just keep moving in the same direction?
Yeah, we did not change our strategy. I think our team definitely felt the pressure, which is good, I think. But yeah, we did not adjust, our roadmap or anything like it. I think it just changed kind of like the perception of the company. We just became more valuable overnight, just like because there was that validation. But yeah, we had our own strategy, we had our own roadmap for delivering the next generation of models, and these things are hard to change. It takes a long time to train these models, and so you cannot really make these kind of sudden changes overnight. And we knew that was the right way to do that. That was the right approach, and we just kept going.
I want to talk about something you mentioned earlier about that 10x better and how that's, it's a requirement, but what it actually looks like. And so you said you thought you needed to be 10x faster, cheaper, better to really compete and to win. Um, how did you decide which of those faster, cheaper, or better? Which one of those, which axis was the most important early on?
Yeah, I would say the most important one would probably be quality. Like if you had a model that is 10x better in quality than everyone else, that's the easiest thing to sell. People when they select a model, they think about these three things. They think about quality, they think about cost, and they think about speed. And the how they prioritize these three things depends on the application and depends on the customer. But generally speaking, the biggest possible TAM, the biggest possible market, you can get there by having the highest possible intelligence. And we can see that with Anthropic, we can see that with OpenAI. Whoever has the most intelligent model is just like creating an enormous amount of value because everyone wants to be able to use the most intelligent assistant, the most intelligent model. The problem is that that's also the hardest one to achieve. And it was not obvious that a diffusion language model would be better on the intelligence, on the quality level compared to an autoregressive model. And it's possible, but it was not obvious that that was the case. All our results from the lab were pointing to an approach that is matching the intelligence while being either faster or cheaper, because you can essentially produce more tokens per second. You can essentially get more tokens for every GPU that you have, which means that you can get one or the other. Essentially, you can make it faster or you can make it cheaper. That one was obvious. That was mostly de-risked. If we can get to the right level of quality, we would be able to make the models go faster, just like because of how these models are built. And so we decided to go for speed or cost, because those things were much more likely to succeed.
Is it tricky though? Because you're selling to very technical customers. I'm not, I'm creative writing English major, right? But when someone says, "Oh, my solution is 10x better, you should buy from me," I'm instantly skeptical because 10x is a big improvement and it just kind of sounds very sales speak, right? So what's the hardest part about communicating like 10x better to customers without overselling or triggering their skepticism? Like these are data focused people. So how do you present that and make it seem reputable?
Yeah, it's we have hard numbers. Our models are benchmarked by third party evaluators. Companies like Artificial Analysis or Open Router, they are constantly basically measuring the quality and the speed of our model. And so what we tell our customers is, look, this is what the model looks like when you benchmarked it. These guys have been testing the model. They are seeing that the speed is indeed 10x larger than these other models that have similar quality that you might be using today. And so it's actually relatively easy to convince them that that is the case. And it's super easy for them to just test and see whether they can get the speed that we claim, that we advertise, because, it's just like essentially one command and you can see that the speed is indeed there. Convincing them that the quality is good enough, that's always a little bit harder, because measuring speed is pretty easy, right? It's like how many tokens you get per second. Either you deliver or you don't, and it's easy to measure that. If you think about quality, is your model really as intelligent as you claim it to be? That is very hard. It's fundamentally an open problem. Like, is Claude Opus more intelligent than some other model? Like, it's hard to measure intelligence, and there are benchmarks, and we can quote benchmarks, and we can show them. On this benchmark we do this well, on that other benchmark we do, we get this score. But fundamentally, we have to convince them to try the model out on the benchmarks they care about, which we don't have access to. And that's always part of the process, that they need to actually evaluate our models, see if the kind of intelligence that we have with our diffusion models is good enough for their application. And so nothing really substitutes them running an evaluation suite against our models and eventually doing some kind of like A/B test where they go in production with our model compared to whatever they were using before, and then they see some improvements in the business metrics that they care about.
With that framing, if you were talking to somebody who, like, advising someone, like they wanted to have a conversation about, validating their idea before they went into the marketplace. If they have an idea that looks incremental versus something foundational, like what you're working on, like, is that not enough to actually want to turn that into a company? Do you need to have something? I mean, it's April 2026. Do you need to have something foundational to come into the market with a new AI technology, or is incremental okay as long as it meets 10x or better?
Think incremental is fine. It's actually good, and from a certain perspective, in the sense that it's probably easier and less technical risk to achieve some kind of like incremental change. The challenge is kind of like what you were alluding before, is that uh, it might not be defensible, right? In the age of AI, one of these companies might make a change to their model or deploy some new harness, and then they can make your whole app or your whole solution completely irrelevant. And so that's always the risk. Like if you stay at the app level or you just put some wrapper around somebody else's LLM, which is kind of like the easiest thing you can do and can create a lot of value, there is a lot of risk because you're always depending on the technology, on these models that you don't own, and you can become obsolete overnight. And so the value is actually created by the LLMs, by the models. That's also the hardest thing to build, but that is the durable sort of like moat that that's what creates the value. So that's why we're focusing on that bit.
So if a deep tech founder is sitting on a really strong technical insight today, haven't started a company yet, but they know they've got something as far as like, I just moved the needle meaningfully, but no one knows yet. What's one concrete experiment they could run in the next 30 to 90 days to kind of de-risk their idea before they talk to an investor?
Yeah, I think it's always trying to think of it from the perspective of the investor, right? So they probably should come up with a plan for, what is the next step? What would be the thing that would convince me that this thing is commercially viable? Uh, and then figure out, okay, how much money would I need to be able to achieve that milestone? And then try to see if there is something in between, maybe is there a way to kind of like trace a line or produce some kind of trajectory that would be useful for convincing an investor that, okay, if you were to spend X thousands dollars, we were able to get here. If you were to put in more, we would be able to get there. So any kind of like experiment, any kind of graph, any kind of like scaling law that it's sort of like showing that, giving confidence to the investors that indeed, if we were to put more resources into this problem, we would be able to achieve the target goal. That would probably be a good investment, because that's sort of like, creating evidence that indeed the solution is scaling, and that, you know, whatever you plan to do, if you were able to raise money, is more likely to succeed.
And then again, also like that first 90 days after your first raise, after like you pre-seed round, the first 90 days after the check is cleared, um, what are your like it's gonna vary from company to company, but what are your as CEO, what are your immediate priorities after that seed round hits the bank?
Depends on the company. We like to work on we work with OKRs, so it's I like that framing. Define two, three objectives that are really, really important for the company. Define some KRs to kind of like measure whether you've been successful in achieving this objective and these goals. And again, kind of like work backwards from, we have some money in the bank. Presumably, that money was raised based on some kind of like plan that involves certain hitting certain milestones by certain dates, and then try to work backwards. Okay, what do we need to get done in the next 3 months to eventually get to the point where we hit our milestones, we're ready for the next fundraise, we're ready to de-risk some other components of the business. And so that's how I would do it.
Anytime ever tried to do anything new, I know there's always a gulf between my expectation and the reality. What was that gulf what was that gap that you kind of didn't expect as far as this is not what I thought this journey was going to be,
Hmm.
but you pivot anyway and go through it.
Yeah, I think what something I wish somebody had told me earlier is how important recruiting is and hiring. That the team is everything, and that you really need to invest a lot of your time and a lot of resources to go
Mhm.
after top talent. I think I underestimated the amount of work and amount of the fraction of my time and the team's time that needs to go into hiring. And in the moment we started putting hiring as one of the OKRs, company level OKR, you need to grow the company in these areas by this much by the end of the quarter, and really get the whole team sort of like involved in the hiring process and really, be very intentional in terms of like thinking about, this is where we are, this is what you need to do, this is what everyone needs to do to achieve those milestones. I think that really changed how successful we were at hiring and how quickly that our velocity. And so I wish kind of like we implemented those kind of processes earlier, and we because they would compound over time, right? So I think that is one thing that I wish we started doing earlier from day one, probably.
Thank you so much. I appreciate the time.
Thank you, Walter. Yeah, it was really good chatting with you today.
The Fund, Build, Scale theme was written by Michael Tritter and performed by Michael and Carlos Chairez. Michael also composed Ocean, the track you heard at the top. If you enjoyed the episode, please subscribe and leave a rating. It helps more people find the show. You can get the Fund, Build, Scale newsletter on Beehive, follow along on Instagram, and if you have a guest suggestion or a question, reach me at fundbuildscale@gmail.com. Thanks for listening. Fund, Build, Scale is a production of Truth and Soul Media, LLC.